Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4 and my name is Muhammad Sufian bin Azhar. Where in our team we have 5 members, which Isamuddin, Farabi, Asfa, and also Chungkiat. So, as before we go furthermore, let's I introduce what we are doing for the project. So our project is to analyze the cycle frame using ANSYS software. ANSYS software is actually in real life industry, and we think this is a very good early expose for learning material. So as we concern about pandemic nowadays, so our team only do 3 cases, not 3 cases, although we have 5 members where we can put one each case, but because of our friends maybe some lacking of computerized program and internet problems, so we done only 3 case with the different forces and diameter. To be clear, for case 1 for case 1 and case 2 we have same force but different diameter. For the case 2, different force and different diameter, so that we can analyze what the ANSYS analysis can be result for. And for your information, our material is using T6061 T6 aluminium. So let's go for the first analysis, is direct stress.
First part for our result and discussion is direct stress. Using ANSYS software, we can get the direct stress for every path easily. So as we know, we have 3 cases, which is for the first cases has normal diameter and forces, and force 2 have different diameter but same forces, and for the case 3 has different diameter and different forces applied. So as we can see from this 3 figure, we can see at the path 2, its appear is yellow, dark yellow, but for the case 2 is red and same as goes to the case 3. So the explanation is, based on the 3 figure, we can observe that there are difference in terms of direct stress. From case 1, we can see that at path 2, dark yellow color is shown, and in case 2 and case 3, a red color appears shown. So from our finding that the direct stress is the stress applied perpendicular to the cross section. So if the cross section area decrease, for example in case 1 it's lower than case 2, so the direct stress is higher in case 1. So it is shown in this figure that in this dark yellow it has 3.2742 megapascal, which is higher than case 2 and case 3.
Next is minimum combined stress. This is the linear combination of direct stress and the minimum bending stress. We have analyzed the bicycle frame with 3 different cases, as in figure 17 and 29, which is for case 2 and case 3 respectively. We can see that the values of the maximum stresses are almost the same, which are 2.27 and 2.9 megapascal, although the diameter and force are not the same to each other. To be compared with figure 6, it is the highest with a value of 7.08, which is for case 1. This is because the area of the small tube is small. As the fundamental of pressure theory, P equals to F over A. The smaller the area, the higher the pressure produced by the constant applied force. The analysis shows the negative value in terms of the mathematics, where it shows low value not in the different direction as understand in physics. Next is maximum combined stress. The maximum combined stress has the same definition compared to minimum combined stress, but this time is maximum. For case 1 in figure 7, its maximum stress is 33.52, which is this picture, while its minimum is 11.53 megapascal. Next, for case 2 in figure 18, which is this one, its maximum stress is 20.39 megapascal, while its minimum is negative 2.192 megapascal. Finally, for case 3 in figure 30, which is this one, its maximum stress is 16.5, while its minimum is negative 2.77 megapascal. As compared from these three cases, the maximum stresses are decreasing in pattern from case 1 to case 3, while for the minimum stresses, it shows a significant increasing pattern from case 1 to case 3. As mentioned in previous section 5.32, the pressure increases when the surface area is small, and vice versa.
Next, we have the total deformation. As we all know, by definition, the total deformation is the vector sum of all directional displacement in the system. And our analysis shows that from all these cases, case 1 has the highest maximum total deformation of 0.42 mm, followed by case 2 with 0.13 mm and case 3 with the lowest maximum total deformation at 0.11 mm. And this analysis indicated that as a beam gets thinner, the more it becomes less strong and easier to bend and deform. However, the analysis also shows that the deformation distributions on the tubes is consistent and similar for every cases. And that is caused by the same basic form from the structure of every case and the force placement for all the cases. Hence, for the total deformation, the analysis indicates that the vector sum of deformations, that is total deformations, are influenced by the diameter of the beams or tubes. That's all.
The graph of the total shear moment diagram for each bed frame has also been plotted up to show the change of force acting on every single length. Shear moment diagrams are analytical tools used to determining the value of shear force and bending moment at a given point of a structural element. This diagram can be used to determine whether a structure in a given set of load can be supported without structural failure. So in this project, the graph has three different trend lines with different colors, which are red, green, and blue. Each color has its represented graph diagram. Red color represents the total shear force per meter length, green color represents the total bending moment per meter length, and blue color represents the total displacement per meter length. Here I take the shear moment diagram of pad 0 from case 1 as an example. The trend line of total shear force was increasing proportional to meter length with 11.985 Newton at 0 meter until the end of the length of the pad 0. While for the total bending moment, it increased slightly with a value of 2.861 Newton meter at 0 meter throughout the meter length. For the total displacement, it has the same trend line like the total shear force, which is also increasing proportional to meter length, with the value of 0 meter at start point until maximum displacement of 0.000264 meter at the length of 0.10154 meter. All the paths from 0 to 3 have its own shear moment diagram, and each of them play an important role in solving the result, whether the bicycle frame structure can support the load without failure.
Alright, in conclusion, I can say that we done this project very well. In ANSYS analysis, we have done total deformation, maximum, minimum combined stress, direct stress, and total deformation, shear moment diagram. So whatever we learn in our class is being applied in ANSYS analysis. But in ANSYS analysis, we don't need to a very lengthy calculation, but just instantly result. But the result is in visualization method. So we need to know what is mean by red color, blue color that represent for. So however, although we done only 3 cases, we do it together. We do it together as a team. Because we can learn it together and solve the problem, whatever the ANSYS solve method it is. So I think our project is done very well and the result is very satisfied. Thank you so much.